Fluorimetry.
الفلوريمتري. Firstly هنعرف introduction عن الفلورسنس وازاي بيشتغل. تاني حاجة هنتكلم عنها هي الانسترومنت، وهنشوف الجهاز ايه مكوناته وايه وظيفة كل حاجة من المكونات دي بتعمل ايه. بعدين هنتكلم عن الدايركت فلوريمتري وهنشوف الاكزامبلز اللي انا بعمل لها determination عن طريق الدايركت فلوريمتري. بعد كده هنشوف ال indirect fluorimetry وهنشوف ال examples اللي انا ما بعرفش اعمل لها determination بالdirect فبلجأ ان انا اعمل لها determination بال indirect. واخر حاجة هي ال quenching وهعرف ايه هو تعريف ال quenching وامتى بيحصل وازاي بيحصل.
ازاي الفلورسنس بيشتغل؟ الفلورسنس بيشتغل عن طريق ان الفلورسنت molecule بيحصل لها excitation by absorption of light، فبيليد ان المولكيول تترانسفير ل higher energy state which is unstable form ومش هيفضل وقت كبير.
بكره هنفضل كده؟ لازم نرجع نقول للناس ايه في الشارع اتجننا؟ يلا.
الوضع ال unstable ده هيخلي المولكيول يحصل لها drop ل lower energy state. Then الفلورسنس هت emit light causing a return to the ground state. اللايت emitted ده يبقى in different color than the originally absorbed light. الفلورسنس بتعرف ان هي ال emission of light through this process.
الانسترومنت بتاعي عبارة عن ايه؟ اول حاجة الزينون لامب ودي بتعتبر السورس اوف لايت بتاعي. اللايت بيخرج من الزينون لامب بينتر الاكزيتيشن مونوكروميتر اللي وظيفته انه يحول البوليكروماتيك لايت اللي خارج من الزينون لامب لمونوكروماتيك عنده only one wavelength علشان يدخل السامبل بتاعتي. الكيوفيت دي هي اللي بيكون فيها السامبل بتاعتي وبتكون مصنوعة يا اما من الجلاس او من الكوارتز. بعد كده السامبل بتاعتي بيطلع منها fluorescence in all directions والfluorescence دي بتعتبر polychromatic وانا عايزة only one wavelength علشان يوصل للديتكتور فهستخدم emission monochromator واخر حاجة عندي هي الديتكتور. الكوينشنج بيريفير لأي process بتعمل reduce للفلورسنس intensity بتاعت أي given substance. المولكيولز أو الأتومز لما بيحصل لهم excitation they tend إن هما يرجعوا تاني للground state by many ways. واحدة من الways دي هي light transmittance as fluorescence. لما بستخدم high concentration المولكيولز بتعمل collision with each other so they lose the energy as heat ودي بتعتبر rapid mechanism علشان a return للstable again وده بيديكريز الانتنستي بتاعة الفلورسنس. in usual case الquenching بيعتبر effect غير مرغوب فيه، والpossibility of encountering this type of interference لازم ان انا اعمل لها evaluation وانا بعمل developing in the fluorometric assay. however الفينومينا دي ممكن ان انا استخدمها في الاناليتيكال means علشان اعمل determination للconcentration of the compounds اللي بتكون to quench fluorescence. الquenching study can be also used علشان reveal localization of fluorophores في البروتينز أو في الممبرينز والpermeability to the quenchers.
Welcome back. Today we will be looking at tonic water and quinine and the effects of fluorescence and quenching. For this experiment you will need tonic water, potassium iodide and a UV light source. Know that quinine, which is in tonic water, fluoresces when exposed to ultraviolet light. This is due to the fact that it has a delocalized aromatic system, and this has delocalized electrons in it which are able to be excited by ultraviolet radiation. When they're excited, the electron moves up to an excited state, then through a non-radiative process the molecule relaxes, and this basically says that it loses energy without emitting a photon. It then goes back to the ground state and emits a photon, and because it's done some internal relaxation, the photon emitted is different to the one absorbed. It has a much longer wavelength, so we can see that as blue light, whereas we can't see ultraviolet light. Now, an interesting thing you can do with things that fluoresce, quinine in this case, you can quench them, and quenching is where you increase the amount of non-radiative relaxation by changing temperature, changing concentration, etc. Or what we're going to do in this experiment, adding another chemical in which has a large quenching effect. And in this case, it quenches it to such a degree that it basically turns off the fluorescing effect. Okay, so here I have 4 beakers. The 2 small ones at the front and the large one at the back, which are all glowing, have just pure tonic water in them. The one at the back left is full of just water. Okay, so I have the UV light just off to the side there at the left. I put them in a line like this just so that they weren't any closer to the light, so they wouldn't be any stronger or any weaker. So you can see the glowing effect. Okay, so I put the 2 smaller beakers at the front. Now what I'm going to do is I'm going to pour water into the one on the left to show you that adding the chemical isn't simply a case of it diluting it. As you can clearly see, it doesn't get any dimmer. If anything, it appears brighter, but this is probably just a volume thing. Okay, so that's what happens when just water is added. But when I add a solution of potassium iodate, which I have here, just swap the beakers around so that it's exposed to the same brightness. Okay, so when I add the potassium iodide, a surprising thing happens. Basically turns off the fluorescing effect, and I can add it to the dilute one and it turns it off. I can add it to the standard at the back and it completely turns it off. I think this is a very neat experiment. If you'd like to learn more about fluorescence, Quantum Wasteland, formerly The Amateur Chemist, did a brilliant video on fluorescence of all kinds of household products, so definitely check him out. Links in the sidebar. Okay, thanks.
Thank you very much.